Alright, I'm back, and let's take a look over here. I had made an error earlier. This was set to write. I've went ahead and changed it to read. Now, you may notice that I've already gone ahead and done the turn block. The turn block's not that interesting. What is interesting is how you calibrate it. So I'm going to go ahead and show you what I've done and walk you through it. It basically exists in 4 parts. We're going to start over here. We're going to start our motors. Now, since we are going to be turning on a dime, we just need the 2 motors to be moving in opposite directions from each other. So I read in my file name. And then from there I read from my my text file. I'm going to read text, and it'll be either left or right. I went ahead and set left as default just because. And when you turn left, you're going to want your left motor to be going backwards. So I set direction to false, this variable dir direction, to false. And down here I set it to the opposite. I set it to the bottom rung, to true. So if you're turning to the right, you want the left motor to go forward. Alright, so over here I'm going to just read out that same thing that I had. I'm going to plug it into my C motor. I'm going to tell it the direction goes that way. This is a logic block that's set to not, and not, all it does is it inverts the value. So if it was true, it becomes false. If it was false, it becomes true. Over here, of course, the result is plugged into the other motor, so they're always going to be spinning opposite of each other. Now here I didn't have any controls for the speed, and I didn't have anything for the duration. The duration is handled over in the rest of the program. This is actually making the motors move is the simple, easy part. Now the reason I didn't change the power and have that be variable is because when you are typing stuff in, it's going to be a lot easier if you don't have to worry about the speed, right? And trying to turn at a speed of 100 tends not to work. You can easily add in speed if you want. All you would have to do is just go over here, read a number, plug it in, and then connect the number out to power on both of them. And there, you're done. But you'd have to remember to include that speed in every single one of them, so I think it makes more sense just to include a default value for speed and use that all the time. Okay, so this gets everything moving, and it's nice and simple and easy. Over here I'm going to read a number, and that's going to be my duration. I'm going to multiply it by some magic number, and for now let us assume that magic number is 1. So I'm going to multiply it by 1. Alright. So whatever it reads, it's going to just put directly in here. At this moment, there's no point in having this math block here. Later, we're going to be able to calculate a magic number that is going to work, that's going to allow us just to say, hey, 90 degrees, and automatically take us there. Now, we have to stall until we stop the motors, because of course the last thing we're going to do in the program is we're going to stop the motors. And I found through experimentation that waiting for a quarter of a second after you stop the motors in this manner really, really, really helps improve the accuracy. So just keep that in mind. 0.2 was too low, and 0.15 actually, waiting for 0.2 seconds was too low, and waiting for 0.15 actually increased the amount of error somehow than just not having a wait block at all. So I have to stall. I have to wait to kill some time. Now, the first thing I'm going to do is I'm going to reset my C and B rotation sensors. And after that, I'm going to read the values in from them constantly. Notice how these are set to reset, and these are set to read. Now, if you were to forget these absolute value blocks, which of course just turns it positive if it was negative, you would see that this turn does not work. That's because one motor is going forward and the other motor is going backwards. So one of them has a positive rotation, the other one has a negative rotation. If the one going forward has a slightly faster speed, if you were to leave it there for long enough, it would work eventually, because it would eventually overtake the other motor. Another problem is that every mini, I forget how many, but every mini rotations, the value will wrap around. It'll go from a very high negative number to a very high positive number and keep decreasing. Or, if it was increasing, it would go from a very high positive number to a very low, very high negative number, like negative 9999, that sort of thing, and increase from there. This is simply because of how computers deal with numbers. They don't deal with numbers in the same way we do. They have a different mechanism for controlling them, for dealing with them, handling them, and that causes them to be a little bit cyclic if you don't take precautions. So over here, I'm going to just make sure they're both positive and find the average. I trust you can figure out how to make an average my block, and I think I've already actually shown how to do that. And I'm going to wait until my average exceeds my intended duration. So that will generate a true value, which will cause this loop to stop. So it's going to bounce out of here. And of course, the next thing it's going to do is to stop and wait for a quarter of a second. Now, this is just how you move. But the problem is, this doesn't actually let you go into your file and do this sort of thing. Turn left 90, move forward 100 for one rotation. Turn left 90, I'm having my robot dance in a square. We humorously refer to it as square dancing, because it will go forward, turn, go forward, turn, go forward, turn, and try and generate as perfect of a square as possible. This is a way to stress test your programming on your turning my block to make sure that it is accurate. Now, how I arrived at this solution was, let me just go ahead and open up a new notepad to describe this. I wrote a program that was like this: turn left for 7,200 degrees. Okay? So obviously 7,200 degrees equals 20 rotations. Now when I did that, I got 6 3/4 of a turns around. Now keep in mind that I'm keeping the words rotations and turns here very separate. A turn is when the robot physically moves from facing, say, north to facing west, then south, then east, then north. Again, that is one turn. A rotation is when the wheel goes about its axis once. Okay? So if you tell it to turn one rotation to the left, it's not going to generate one turn. If you tell it to spin for one rotation to the left, it's not going to generate one turn. A turn is its space and its heading out here in the real world. And the rotations is just what the motors understand as the motors spin around. So there's a disconnect, and we have to figure out what that is. Thankfully, it is a ratio, and we can figure that out. So it is 6 3/4. 6 plus 3 divided by 4. It was actually a tiny bit more than that. It was about 1/32 more than that. And I just took my hand in between 3/4 and a full turn, and notice that was 7/8. Then I moved it into the halfway point again, and the halfway point again, and went down until I found that it was 6 and 25 30 seconds. Which, if I multiply all that out, gives me 217 divided by 32. So I had 217 divided by 32 turns equal to 20 rotations. Now, all I have to do is solve this ratio to figure out how many rotations equals one turn. So to do that, I multiply both sides by 32, and I get 217 turns equals 640 rotations. So if you really, really want to, if I really, really wanted to, I could put in 640 rotations, and this thing would turn around 217 times exactly. But I don't want to do that. I want to figure out how many one turn is. So I divide both sides by 217, and I get 640 divided by 217 rotations. Now, my calculator tells me that that is about one turn equals about 2.95 rotations. So I went ahead and I tried that on my, I changed this number here from 1 to 2.95. And I went ahead and I tried that on my robot. And this time, instead of going around 6 3/4 and a little tiny bit more, it went around 19.75 times. So that is to say that after I changed that multiplier from a 1 to a 2.95, I got 19.75 turns equals 20 rotations. Now, if you are to multiply all this out, you would see that you needed you see that 19.75 is the same thing as 80 divided by 79 divided by 80. That's one way of doing it. Or you could just note that you needed to that this was your 2.95 value here was a little bit on the low side, so you're going to need to multiply 2.95 times 20 divided by 19.75, which is 2.95 times 80 divided by 79. Now, clearly 80 divided by 79 is very close to 1. It's just a tiny bit over. And in fact, if I multiply that out, I find that it equals roughly 2.99. Alright, so if I replace this value with 2.99, and I went ahead and tested my program, this one, that has its square dance, has it go in 3 complete squares, and it ends up, I would say, maybe 5 degrees off. So instead of creating this weird little triangle shape or messing around and just going all over the board, it stays pretty close to what I would want. You can tweak it further, but you definitely are really close to the value that you want.